MATLAB class, the name of our final project is using MATLAB to assess Q angle during gait.
So gait is basically just a fancy term for walking. The Q angle is the distance from the pelvis here down to the center of the knee compared to the vertical, so that is the calculated Q angle here. So in our, some of the Q angle norms for females is less than 22 degrees and then less than 18 degrees for males. The importance of that is the fact that a larger Q angle puts a lot of stress onto the knee. So a lot of times during walking, when we take a step, our Q angles can increase. So we used anthropometric measurements. So basically, we use this device to measure the knee width and the ankle width, and as well as using this to measure leg length. And we also took height and mass measurements as well for our Vicon system. We then placed reflective markers, such as this, into 16 anatomical points, here being in the pelvis, the thigh, the knee, and then down in the ankle were some of the locations of interest that we used for our, to calculate Q angle in our code. We performed walking trials, barefoot, with shoes, and with a heel insert. And the reason we used those three different ones is because there could be a change in the Q angle, which is our interest.
Hi, my name is Jiunan. I'm presenting Vicon Nexus program, which tracks the motion data and extracts their 3D coordinates. All walking trials were captured by motion capture system, and 16 reflective markers were presented as gray circles in 3D perspective. To identify body length marks position, each marker must be labeled correspond to a predetermined template. After labeling, a person's bodies appeared as a yellow stick figure. Because we attached markers only to the lower body, the stick figure only shows the participant's hip, thighs, legs, and feet. We can confirm that our walking trials were captured very well by playing back with multiple directions. We extracted motion data as CSV file. A marker's position is identified in X, Y, Z axis, and they are exported to MATLAB.
There are instructions here at the beginning. We have the measurements for our subject in this one. It immediately converts the data over into INT64 to remove the formatting, and then we move it back into double. So we do lose a little bit of accuracy. Each one of these is the 3D coordinates, and then we use calculations for knee joint center and ankle joint center. This right here calculates the distance between the two markers on the front of the pelvis, which is then used in this section to where we can calculate the hip joint center using this coda pelvis calculation here. This right here just plots all of those 3D points, and we have a little special bit for the for the hip joint centers, and then the part of the data that we're looking for that's the most important. So we're looking at the min and max of the left and right, and it's just due to the 3D coordinate system in our laboratory. And then this right here just kind of creates a nice line between them so you can see exactly what you're looking for. And then this section is just to determine or to give you a printout if the person is male or female, and if their knee is in a healthy range. So we're just going to kind of run through it real quick. So here, boom, and we get this very nice graph, and that's all of the data points traveling through space, and then we get the exact moment that we're looking for within that time frame of the knees and their angle, and then we input that the user is male, and the script gives us this this bit here where it'll show us that they're in a healthy stance.
So for the result in the thigh angle, we see the left and right thigh angle is different in barefoot condition when compared to the with shoe condition and with sole condition. For the barefoot condition, as we can see, for the left thigh angle is 17.7 and the right thigh angle is 16.5. With shoe it is 13.5 and 13.7, and with sole it's 8.3 and 8.9, which is a huge difference from the barefoot condition to the with sole condition. Here is the graph of the tree condition. So we present the y and the z axis, and the blue line represent the left leg and the red line represent the right leg. And if we look at the first figure, second figure, and the third figure, we see the Q angle in barefoot is different than the Q angle in shoe condition and in sole condition. So from the result, we see that the MATLAB code that we used to assess Q angle was successful distinguishing the Q angle during gait in different gait situations.